Before we move on to understanding the concept of a unit circle, let us review what we did previously. The code we use to remember the formulae is cosθ. So tells us that sine theta is opposite by hypotenuse. Ka tells us cos theta is adjacent by hypotenuse. And th tells us tan theta is opposite by adjacent. These are the three basic formulae we use in trigonometry. But how are these three functions related to the angle theta? What happens to them when theta changes? Are they directly or inversely proportional to theta? All these questions can be answered with the help of one concept called the unit circle. The concept of this circle is very simple. To represent the Cartesian plane, let's draw the x and the y axis. The unit circle would look like this. It is a circle with radius equal to 1 unit, and it has its center at the origin, which is the point at which the x and y axis meet. Let this point O be the origin. And remember, this is also the center of the circle. Notice that the circle meets the x-axis at 2 points and the y-axis also at 2 points. Let's find the coordinates of those points. This point lies on the x-axis, which means its y-coordinate will be 0. As the radius of the circle is 1, its x-coordinate will be 1. The coordinates of this point will be 1, 0. What about the coordinates of this point? Simple, it will be -1, 0, as it's on the negative side of x-axis. What about this point? As it lies on the y-axis, its x-coordinate will be 0 and the radius is 1 unit. Its coordinates will be 0, 1. Similarly, the coordinates of this point here will be 0, -1. This is the unit circle. But how does this circle help us understand the relation between theta and the trigonometric functions? Let's see. Let these be our x and y axis, and let this be our unit circle. We draw a right triangle this way. We draw it such that the hypotenuse of the triangle is the radius of the unit circle. So the hypotenuse will be 1 unit, and we let this angle be theta. This triangle is the same one we have seen earlier, just that we keep its hypotenuse equal to the radius of the unit circle, which is 1 unit. Let's call it OAB. In this triangle, OB is the hypotenuse, OA will be the adjacent side, and AB will be the opposite side. Now let's apply the formulae and see the results. First, let's find out sine theta. It's cosθ, so sine is opposite by hypotenuse. Opposite is AB and hypotenuse is OB. So sine theta will equal AB by OB. But what is OB? OB is equal to 1 unit as it is the radius. So sine theta will be AB. So this length AB is sine theta. We write sine theta next to AB. Cos theta is adjacent by hypotenuse. Adjacent is OA and hypotenuse is OB. Hence, cos theta will equal OA by OB. And as OB is 1 unit, cos theta will equal OA. So let's write cos theta under OA here. OA is cos theta and AB is sine theta. What about tan theta? Tan is actually a tangent function. The length of tan theta will be the length of the tangent from point B to the x-axis, which is the length of this green line. This green line touches the circle at just one point, which is point B. This length will be tan theta. From this figure, we have the lengths of sine theta, cos theta, and tan theta. Now to understand the relation between the angle theta and the functions, we just have to try changing the angle theta and see how these three lengths change. We see that in the next part of the video.